Hello everybody, my name is Zorz. I come from Slovenia. I work for Internet Society, and this time I would like to talk to you about some experiments that I'm doing in my lab back in Slovenia. So, what is the problem statement? So, I call it 6 degrees of inner turbulence. Let me walk you through the problem. IPv6 and IPv4 are incompatible on the wire, fundamentally. They're like ships in the night. They don't know one about the other. They are on the same link, they're on the same physical link, but they don't talk to each other. So we need translation and transition mechanisms between the two protocols. For example, mobile operators are massively moving to IPv6 because there is no good incentive to use IPv4 and IPv6 on mobile phones. They just use IPv6 only. That means that we have in T-Mobile USA, for example, as we speak, they have around 52, 53 maybe millions of devices connected on IPv6 only. And all these people is going through the NAT64 translation mechanism that is in the core. So the Android is by default from version 4.4 and up is using 464 XLAT to actually mitigate some of the issues that are with DNSSEC and NAT64. And Apple is using NAT64 as a transition tool to access IPv4 content. So some people does weird stuff while adding quad A's to their DNS records. And also some people is hard coding IPv4 addresses into their web content. And we have important 2 questions to ask. So, do content providers know how their content will be seen from such environments? If you are providing content, you want everybody to see your content. That means that's why you put your content online. So, do you really see how people is accessing your content, how your content is seen from these environments? And do connectivity providers, like mobile operators, know what their users' experience on IPv6 only would be? So I had these 2 questions, because I travel a lot, I tell you. And I speak to operators around the world, and they tell me the same thing. So should we implement this NAT64 and then we don't know what the user experience will be? So how can we check that people will not call our help desk that everything is broken? So yeah, I started this discussion, and then we started doing some testing. Okay, let's get this out of the way. Credits, acknowledgement, and supporters. I would like to thank Internet Society for letting me do all these experiments in my lab to use my working time. To do this crazy stuff, and also to send me around the world so I can talk to people about stuff that we do. Go6 Institute Slovenia for enabling and maintaining the lab environment. Then Sander Stefan for his working time. He actually coded the tool that I will show you at the end. And also Karin Pritchard for a lovely design of a tool's front end. Hugs to Karin, if you're watching, that's Sandra's girlfriend, and she did really excellent design for the tool. All right. So some time ago, I wanted to understand how NAT64 DNS64 works. So I set up in my lab, I set up 4 different implementations of NAT64 that you can use, not from here because there is no IPv6 on ENOG Wi-Fi, but if you would have an IPv6 here, you would be able to use them remotely, because I'm using global IPv6 addresses as NAT64 prefix. So if you point your recursive DNS setting on your Mac or Windows or whatever you have to one of my DNS64 servers, then you disable IPv4 and all your traffic will start flowing up to Slovenia, gets translated, and then you get the content back so you can also reach IPv4 content. And is it currently used by operators? to test remotely how NAT64 translation works. For example, I got an email from Google guys, and they said, while we were deploying 464 XLAT into Android, because it's enabled by default, we tested the code remotely from Japan against 4 implementations in your lab, and they said, and we found that with one of them, the whole thing was acting weirdly, so we actually fixed the bug, and now it works with all the implementations. Jan, thank you for running this stuff, so we could test remotely. It's also used by application providers to see how their application works in NAT64, DNS64 environment, and also by hardware and software vendors that they are testing their solutions against multiple NAT64 vendors. There you have a link. If you click that link, there are instructions how to access this stuff remotely, and it's open, it's free. Use it, see how it works. But you need to have IPv6 in the network where your machine is. Okay, this is a screenshot of the instructions, and as you see here, I'm running the A10 networks version. I'm running Palo Alto Networks firewall with NAT64. Then YOL, it's a NAT64 that's open source. It is basically a kernel module for Linux. This one is the easiest one and actually works pretty well. And then Cisco shipped me an ASR1K to my lab that's sitting somewhere, and it's actually providing the NAT64 translation function. This is our lab. Sander calls it systematic chaos, and it is a little bit, but you know, it's a lab. It just works. This is the real hardware. It's not something virtual somewhere. This is actually provided by the hardware. Okay. So when I got this up and running, lots of people started using it, and then from time to time I go into the log files of these devices, and then I started noticing some weird stuff. And then I went further into it, and then I realized that actually there is people on this planet that are putting weird things as a quad A record. So have you ever seen any of these values? People put column as a quad A record. That's not going anywhere. This will not work at all. Then people put in column 1. That's your local host. So if you run a web server and you put the quad A of your local host, you will maybe see your content, but nobody else will see your content. Then people put in column FFF and IPv4 address. This is not going to work. FE80, link local, what the hell? 64FF9B, that's a well-known NAT64 prefix, also not going to work. And 2001 DB8, that's a documentation prefix, that's also not going anywhere. I've seen these quad A's and I got curious. And if you see something like this, please call the guy and say, hey, please put some tobacco in what you smoke, or remove quad A and fix it, right? So Dan Wink is actually doing the research on this, and he's running the scripts to measure this. There is a link. There is lots of people with weird quad A's. Problem is that with DNS64 and NAT64, if you have a quad A, DNS64 will not synthesize the quad A record for you. It will just pass on untouched quad A record. And it will not, your phone will not show the content if you are on IPv6 only. So for example, firstinside.com with www, it's okay. Without, you see the IPv6 address is column. That will not work properly. So what we can do about it? Okay, I understand in the lab, then there you need to figure out all the brokenness and things. But in real life, you don't want your users to have bad user experience. You want to fix it. Remember, if you are not part of solution, you are part of a problem. Always remember this. That's an old operational saying. And I figured out in a configuration of DNS64, there is this exclude statement. So IANA allocated 2000:/3 as a global unicast address pool. So that means whatever else is used in Quad A, most probably it's bogus and broken. So what can we do? If you're running bind, this is the example of DNS64 configuration. You see there, exclude 0:/3, that's the first part. Then we include 2000:3, and then we exclude the rest, and also 2001 DB8, because this is a documentation prefix. So with this, what explanation of exclude says that whatever is outside this global unicast address pool, if the DNS server receives the answer that is the Quad A, that is anything outside this, it will just discard it, throw it away, and synthesize the NAT64 prefix plus IPv4 address record Quad A, and then pass it on so people can at least connect in some way. Yeah, so with DNS64, there is a moment of betrayal here. I love DNSSEC. I like it. I signed all the zones. You know, in the lab, I'm doing KSK rollover and all this stuff. But with DNS64, you need to break DNSSEC. Because if you don't have a Quad A record, and DNS64 will create a Quad A record for you, then you don't have the key to sign this Quad A record if the zone is signed. So it will break a little bit. It's not very, it's semi-broken, basically. But, so this means if you sign the zone with DNSSEC, do also IPv6. Because if you will not put Quad A record in your zone, somebody else will create Quad A for you. Mobile operators, 52 million devices, they will create a Quad A record for you. And then the experience of a user is not in your hands anymore, but in the hands of some translation device. So yeah, we need to put in the break DNSSEC configuration directive. So let's see this Enigma machine. This is without break DNSSEC, yes. And if I ask for 4.go6.si to my DNS64 server, you see there is a Quad A, there is no record, there is no response because DNSSEC is broken and the record doesn't exist. With break DNSSEC, yes, you see 4.go6.si all of a sudden becomes NAT64 prefix, column, and IPv4 address in hex format. So this is then useful for people in IPv6 only environment that they can connect. All right, I will go a little bit faster. So stream of consciousness, also for Unbound, whoever is using Unbound, you see private addresses. These addresses will be discarded from the response and Quad A will be synthesized for you. If you want good for your users and if you are using NAT64, you should do this. There is quite a good RFC written by our friends about DNS64 and DNSSEC, how it interact and how it works together. Please read it. It's quite a good one if you want to understand these things. And now let's see some examples. For example, firewalls.com. This should be secure, right? I'm still waiting for the timeout. Indeed, it's very, very, very secure. Oh, it's running on column FF and IPv4 address. That is very secure. And NAT64 will not work because it has a Quad A record. This is Spain. I heard from Jordi that this was fixed. So here you can see that IPv6 and NAT64 version of the content is completely different from the IPv4 version. Then we have here from Slovenia, of course. This is broken geolocation tool. Because despite the fact that I was sitting in Go6 lab inside Slovenia, in the middle of Slovenia, on IPv6, it decided that I'm not in Slovenia. So, yeah. I cannot put files on this service because I'm not in Slovenia. Well done. UC.cn, you see the difference in content representation? Well, so for example, this one, this is German people. If you're selling stuff, people will not buy. People from IPv6 will not buy this because there are no pictures. People will not click on them. So you lost a customer here. It will not work properly. The Gateway Pundit, you see the difference? Then you have, these are examples of this household church. They actually implemented IPv6. They put in the quad A record that is correct, and the server is responding. You see 22 milliseconds. But the web server did not listen on IPv6. It will not work. So people will not be able to go and see the household church, whatever that is. Then you have working quad A records and IPv4 only content. And if you want to understand what's going on here, then you see that resources match. You click on that triangle and it will show you sort of like all the stuff that is going on and how it is loaded. NAT64, IPv4 only, and IPv6 only. You see here is the bad gateway. So it just received back the bad gateway and game over. So see, there is lots of stuff going on, lots of possible mistakes that people can do when enabling IPv6 for content. So what is the looking glass? How to test for all these things? Test on NAT64, test on IPv6 only, did all resources load okay? Does it look good to the user? How do we see any path MTU discovery issues? And there is one service to test them all, NAT64Check. So I had all these questions and we discussed with Sander one day. And then what happened was that I'm not a programmer. I'm a lousy programmer. And I started to put together some code. Basically, it was bash scripts with a little bit of Perl. And when Sander saw my prototype code, he just said, "Sir, step back from the keyboard and delete the whole thing immediately." And he started coding in Python. So that was the way how I persuaded Sander to actually go and code things. So this is the tool. If you want to check your website, how it looks like from all these environments, there is the link. It's nat64check.go6lab.si. If you type that in, and then you have this check box, you just type in your URL and press the green button, and it will start doing the test. How does all this thing work? Okay, you have some filtering there. Examples. I will explain later how it works under the bonnet. For example, this one, we tested. This is some, I don't know which site is it. Yeah, some Japanese site. If you do the mouse over, it will show you the difference. See the difference? If you do mouse over, it will show you the difference, how your site is different from IPv4 only. Here, we don't fix brokenness. This tool is talking to a DNSSEC server that does not exclude anything. If you put column in your quad A record, it will tell you it's broken, and it will clearly tell you it's broken. So we don't fix brokenness because we want that all the brokenness is actually discovered and fixed. How does this work? Some illumination theory behind this. 4 servers. There is management server and web interface. That's the one that you connect to and put in your URL. Then you have server with only IPv4, server with only IPv6, and server with NAT64. And we are using Phantom.js. I understand from Sander that we will move to some Chrome-based tool because Phantom.js is not supported anymore. Phantom.js is a command line browser, and it keeps track of all loaded resources, and then it makes a screenshot. So how this all works, when you put in the URL that you want to test into the master and web interface, it talks to all these 3 servers and tells to the command line web browser, okay, go there and fetch the content. This is the URL that you should connect to. And then this command line browser gets back whatever it gets back, makes a screenshot, and then reports back to the master server. And master server gets all three pictures and responses from all three environments, and then does the matching of the pictures. So it matches the pictures and changes, and it also matches the elements if they all loaded in the same manner. So there is quite a lot going on under the bonnet. So please take the time. When you press the button, it will start the measurement. Be patient, because sometimes there are timeouts, that some elements don't load, and then you need to wait for all the timeouts so the result comes back. Take the time. Be patient. So, wash, rinse, and repeat. Test your website. Are you sure that all the images, analytics, scripts, do they load over IPv6? I see many cases where just CSS styles or some weird scripts from third-party servers do not load okay, and then your site looks weird. If you don't have IPv6 on your server, and there is no reason of not having IPv6 on your server, but if you don't have one, if you live in the past, did you hard code any IPv4 addresses in your HTML code? In this case, DNS64 and NAT64 will fail. And why do you don't have IPv6 anyway? It's your problem. So if things fail, make sure that you find the issues and fix them. Fix the issues and do another test. And repeat until done. I got lots of feedback that people had problems with DNS. You need to understand that DNS has a TTL, so fix your DNS and wait for the new zone to propagate across the internet and to our DNS servers. This is not working just in a couple of minutes. It takes time. So DNS propagation is slow. For example, this is the example of non-working domain. You see qq.com as SOA record was not a subdomain of the NS3QQ.com. With normal DNS, you can get away with it. With DNS64, this would just fail. So you need to have a healthy domain without errors if you want your users to see, the users on IPv6 to see your content. The good thing is, this tool is free, it's open, and we put the code on the GitHub, and feel free to use it, to contribute. We are looking for volunteers from the community that can code in Python, that will help us with the second version. Now currently the work is being done on the version 2 that will include sort of like the distributed nodes. So we will have two, I call it Yoda, but I think Sander named it Zaphod, Bibelbrox. These are the masters or kings of the universe, and they will talk to all other nodes that will actually do the testing and will be distributed around the world. So when the version 2 comes out, we'll be also looking for the volunteers to run this test node in as much networks as possible, so we can have global view on how the content is seen from different sites. So, conclusions, suggestions, questions, the spirit carries on. We are working on version 2, and if you're a content provider, test how people see your content from different environments. If you're a connectivity provider, test how IPv6 only and 464 XLET users sees your content. If both, all of the above. You might be surprised. You might really, really be surprised how your website performs. Also, take care of the path MTU discovery. Lots of people messes up the path MTU discovery, and because our test is sitting on IPv6 connectivity that is MTU restricted to 1280 to simulate the tunnel. So if you broke the path MTU discovery, the test will fail. That's it. Any suggestions, questions? Did you do the test? How did it go? If you have any suggestions for improvements of the tool, now it's time because we are working on version 2. If you don't come to the mic now, then I'll be around for the whole week. Come to me and talk to me. I'm open for all suggestions.
Wait. Да, если у нас вопросы, мы, в принципе, уже вылезли немножко за границы.
Actually, we are beyond the agenda right now, but still, if you have the question, I have a question to address to the audience. Who is hosting, who has the website and tried to use this tool? At least one we have, two, the third one.
Сайт ENOG работает, я только что проверил.
Okay, Jan.
Mine works. Jan?
People using your tool during this meeting?
Yeah, I do this presentation.
Да, я выступал с этой презентацией в Южной Америке, в Африке, и я вижу во время моего выступления, что наблюдается рост, все больше и больше количество людей начинают пользоваться им.
Crashed.
That was the first one that we tested.
I thought so. Okay. Good. Давайте еще раз шанс. У нас есть.
We have two microphones. One is nearby and the other one is a bit far away. If you have any suggestions, any comments, if not, then we will wrap up this session. Please do not forget to go to the website and rate all the speakers, all the presentations, and at the same time, please watch our ENOG channel. And there is a larger discussion now. It is much better than ENOG Talk channel. Thank you, Jan.